We're live. It is 7:39. Hopefully everybody's doing good. Tonight we're going to talk about intercooling, and more specifically, we've talked about intercooling a lot, but we're going to talk about air to water intercooling. And just as a refresher course for the people out there, air to air versus air to water, we know that when we supply both of them, when they're sized correctly, and we supply both of them with the ambient water on the air to water and ambient air on the air to air, that they're going to do similar things. I have tests up where we've done that, and they work very well. And people can argue back and forth about the response rate and all of that. And that ice water makes the air to water better in every single way. You can't use it all the time. There's all this back and forth stuff. There are people out there, unfortunately, that still. It surprises me that there are people out there that actually think that you can take an air-to-air intercooler and, run heated charge air through it, like 20, 30 pounds of boost or whatever, and have, let's say it's 80 degrees outside, and have 80-degree air cooling that, and then somehow get the air temperature below the ambient air. I'm like, that's not a thing. It doesn't make any difference how good the air-to-air intercooler is. That doesn't work. That's not possible. The only way to do that is that you have to have the transfer medium be colder than the discharge air. That has to happen. Otherwise, you're not going to lower it below the ambient air outside. That's why ice water works so well, because you have a 32-degree transfer medium, and if it's 80 degrees outside, not unusual for the air going into the motor, even after going through the intercooler, even if it started out at 200 degrees or 250 degrees, it's not unusual for it to go down below ambient, because we're cooling it with something that's 32 degrees. And if you did it with something even colder, like liquid nitrogen or something weird, then you could get even cooler. That's why the compressed air supercharging stuff works so well, because the discharge air going into the motor is below zero, and that's it's hard to get better than what they're doing with that. But what I want to talk about tonight is something more realistic. It's the air to water intercooler, and not specifically although it applies to both things here. If we look at an intercooler, like if you look at the thumbnail that I have up, that's the core that we're using on our kits. It's an air to water. I like those cores. I've done more than 1,000 horsepower of that core, and it works good. And so we wanted to size it so it was capable of, suiting the needs. Like, I'm not interested in going, pro mod racing or even, I don't think, unless guys are running in some class that is not running fours or something in the eighth, even doing no prep stuff or whatever. It's not sized for that. It's sized for the regular guy. It'll go into 4-digit power level, and that takes care of a big part of the market, I would argue. But the one thing we want to look at on these cores is, when running through this, and this sometimes happens with the discharge air going through the core. If it goes in and out, that's what we call a dual pass. And this is not uncommon. And the reason that I showed the thumbnail that I'm showing is, if you look at the one of them, those on the top is the water in, and the other one is the water out. So the cooling water that's cooling the charge air, the heated charge air, goes down into one side, and this is sectioned off with an opening down at the bottom, so the air can flow through the core on this side and then come back up and then flow out of the core on the other side. So here's the question. The way that this works is, the colder water, presumably, even if it's ambient, it's still going to be colder than 200 or 250 or more degree charge air going through it. So it's going to be cooling. So that water is going through, the boost is going through that, and then it turns and it comes back out, and the boost is still going through it, but it would have already picked up some heat from its first pass. And so it's probably no longer 80 degrees, coming back out. If it was 80 degrees going in, it's no longer 80 degrees on what we call the second pass. So it's coming back out. It's still going to be way lower than the charge air is. It's not going to be 250 or 300 degrees. It's still going to be way less than that. But the argument is, the logical argument is that that is less efficient. And one way that people get around that, and you can do this, and it's something that I've wanted to do on the twin core intercooler that I used for all the Big Bang stuff and for lots of stuff. That's something that I wanted to do. In fact, that's something that Gail Banks had called me and pointed out. He said, well, your water pump is not big enough for what you're doing. He said, the amount of power that you're running. He said, and also you got, twin passes on these intercoolers. He said, you need way more water flow. He said, it'd just be better to have, I said, I know it's better to have a single pass, just have 2 inlets going in and 2 inlets coming out, and just have it go through there and just have it go from one side cold. And then, by the time it reaches the other side, it will have taken some temperature in, but at least it's only going one pass. And so a single pass like that obviously is much better. My question for all of this is, does that matter? I mean, we know it matters, but does it matter? Does it matter enough to matter? So if we have, because I've run lots and lots of air to water intercooler stuff. In fact, I usually run that. I prefer that on the engine dyno only because we have an inexhaustible supply of water from the 2,500 gallon tank that we would use for the dyno at WASTEC. We could also, if we wanted, just run groundwater. We could run well water or city water or whatever, and run that through the intercooler and just drain that into the tank, because there's more than enough room in this 2,500 gallon tank. If we needed to put a little bit of extra, 10, 15 gallons of water in it or whatever, wouldn't ever even notice that. And then we could turn it off while we're not using it. So we could cool that. And we could also, when I set up ice water in these things, I have a dedicated, I usually use the fuel cell that I have, and it has a big outlet on the bottom that feeds the electric water pump. And then we run the water going through and then run ice water through it and do all that. But that's a sealed system and doesn't evacuate back into the dyno. So that's easy. It just recirculates back into where the ice bath is, basically. So it just grabs more, gets more cold water, basically, to keep it nice, like an icy chili kind of thing. So that works. But the question is, the reason that I ask this is that I've had people tell me that yes, a dual path intercooler like that is terrible. It's the worst. I'm like, well, it's not the worst because I've used it a lot and we've measured the temperature drops on a lot of stuff, and I can tell you it's very, very effective. I haven't yet measured the water temperature going in and then at the turn and then coming out to see what the temperature differential is. I think that would be interesting. I'd never done that, and I can't believe it didn't occur to me to try that to see. But usually a dyno pass is so short that I think that there's less time for that to actually happen. Now, we know that it's imparting temperature from the charge air into the water via the surface area of the intercooler. We know that because we have a dramatically lower air temperature. The difference between the air going in from the turbo or the supercharger to the air coming out is much, much colder. So that heat had to go somewhere, and it went into the water. And so we have enough. The thing about this is that, like when we're running it on the dyno, we have so much cold water that we can run through there that's not an issue. We don't have a recovery rate situation. But, short of that, does this make a difference? And the reason that I ask this is because I have done some other tests. I've done tests where we've not circulated water through an air-to-water intercooler, and it actually worked fairly well because it still has lots of surface area. And as long as it's not super hot and you make a pull, it actually takes temperature out of the air. Not as much as if you have lots of water circulating through it. And on a short pull, it's more effective than it would be on some sort of long pull. And then I've also done a test where we've just left the water in there and not circulated more water in there. And that actually works fairly well, especially on one pull. If you do multiple pulls, which we did, it starts getting, it starts heating the water up and starts getting hotter and hotter. And you don't want to get it to the point where the water would get so hot that you would be boiling the water, because it's not unusual to have, temperature from the turbo going into the intercooler that would be above the boiling temperature of water. And we're just using water. We're not using, you know, ethanol or glycol or anything. We're not using coolant. It's just water. So you could easily put enough temperature in there if you kept doing it to raise the temperature of the water and get it to boil. You don't want it to do that. But we were just making single passes, which takes, you know, 6, 8, 10 seconds, whatever, however long the dyno pull takes. It's not very long. But when you're on the street, or if you're doing a roll race or doing something on the freeway, you don't want to do the silver state like that. That would be foolish. But my question is, you know, does this matter? Is this like if this was an all-out thing and I was building a Pro Mod motor, they would be single pass because that's the best. I know that that's the best. And even if it made no difference, which I think is the situation in a lot of these cases, that I don't know that you'd be able to measure the difference in charge temperature or in power by changing from a single pass to a dual pass. I don't know that you would see that. I think as we go up in boost and go up in power and go up in temperature, that thing gets more, there's more potential for that to make a bigger difference. But I think, like, for what we're doing, I don't think it makes any difference. We run so much water through there that even if it was a single pass, I don't think it would do anything. When we're doing the 1500 horsepower stuff and we have less water flow, because the pump from the dyno flows a lot of water, flows more than the intercooler probably could take. But when we're using I think we're using a Mazir electric pump, the flow rate of that is not nearly as much as what the dyno is capable of doing. When we have a valve that we just crack open basically from the dyno and from the water pump, and we don't flow it all the way because it would be way more than it needs. So we just open it up, and I have a hose at the end that I'm looking at. I'm like, oh yeah, that's flowing a lot. Just judge it by like, oh yeah, that's a ton. But the one on the intercooler, when we run the ice water stuff, is not as much flow. And I'm like, well, but we're offsetting that by it being 30 degrees or 32 degrees or whatever. So it's probably fine. And it is for short pull for what we're doing. But I would like that to be more, because if we're talking about, 30 pounds of boost, we're talking about more temperature. And then depending on whether we're running that in the summer or whatever, it could be more or less problematic. But let me know what you guys think. We'll put that up as a poll. Okay, is a single pass air-to-water intercooler really a benefit compared to a dual pass on a streetcar? We're going to say streetcar, just, because. Cool the charge error however you can. I agree with that. I just don't know that you'd be able to even see a difference in charge temperature. Spray the intercooler with nitrous. Oh, yeah, we've done that. I've done that test before. The like button will drop your inlet air temperatures by 80 C. That's a lot. Water methanol injection, only if you did it on the intercooler. On the garage as we speak, starting the 4L80 swap. Nice. Cam header swap, all-wheel drive to two-wheel drive. You're doing lots of swap in there, man. Swap till you drop. What do you think about air-to-water intercooler that goes in between the high ram? I think they're a really good idea. They work well. I've run the tick one a few times. Richard, have you run or seen the new ProCharger LT1 intercooler intake for direct injection? It has a brick-style intercooler built into the billet intake, kind of like the tick one. I think that those are good as long as you have, it's like any intercooler. You just have to have enough surface area and for cooling. And then you also want to simultaneously, minimize flow restrictions, which the two things are at odds. And then, like we were just talking about, make sure that you have enough liquid flow going through it. But those things, where they're positioned, can work really well. Gail Banks is the man. Yeah, he's done a lot of stuff. Just racing performance checking in from Phoenix. Which is a tweaker geographic. Where do you find your air to water intercooler? Will you start selling them? Yeah, we're going to sell that core. That'll be part of our turbo kit. Does a tick brick? Tick brick. They should call it that, right? Solid intercooler affect the way the Holley LT1 higher RAM performs, RPM range, boost drop. No, it's not going to change the effective RPM range. None of that's going to change. I don't, probably at most power levels, it's not going to change. It's not going to be a restriction. But at some point, it would be. I just don't know how big it is, how thick it is, what the flow rate is. But they could probably answer all that. They can answer how far they've taken that thing. But there will always be a boost drop across an intercooler because you've changed the temperature. So the pressure will definitely change. Not because of a restriction, because of temperature. Then also because of a restriction if it has that. Richard, glad to hear everybody's okay. What do I need to do to mate a 307 small block Chevy block, TBI 193 heads and L-Rock Street master intake? Wedge washers, do I use a 350 400 head gaskets? I don't know. More than likely a 305 head gasket, right? What's the bore size on a 307? I don't know about the TBI heads. I don't know what bolt pattern that has. You might have to drill and or use those little angle spacers that sometimes they provide those with the intake manifolds. Started my 6-liter build this weekend. Have you seen the all-built one-piece Pro Charger intake? It's probably the best all-in-one package. I'm just wondering, the RPM range is also very expensive. I don't know what you mean by the best all-in-one package. I don't need crazy high horsepower one. That's my cart now with the Holley intake. Got a tick intercooler, I think 2800 for the combo. What side will your single turbo be on, the passenger or the driver? It's on the passenger side. Their videos are up on it, Edward. There's videos on the turbo kit on a prototype that we tested on Jimmy's Tahoe. .307 small block is a 4-inch bore. I don't think there would be much of any difference if both style intercoolers are physically the same size. I don't remember the bore and stroke on a 307. It's just a short stroke. .307 has a 3875 bore and a 3250 stroke, is what it says here. I thought that it was a short one. Thanks again for all the tests. I was thinking about you today when I saved the life of the biggest diamondback rattlesnake I've ever seen. This guy was close to 7 feet and not very happy with me. You should save him, and that's probably a world record if it's 7 feet and it's a Western diamondback. Yeah, I thought that the 307 was closer. It was smaller. Have you done any Godzilla testing? I haven't. I don't have one of those. But the guys at WASTEGATES have one now, and I'm actually waiting for a call back from my buddy from VORTECH because they have one there. Oh, and I made well, I made some mistakes. I've made lots of them in my lifetime. But I'm changing my position on boring out both 6-liter iron blocks and on boring out 4.8 and 5.3 blocks. And you guys will see soon, I'll be doing a video on the 4.8 block that I just had magged. And then they're boring it, I think, on Monday, and then we're going to retest it. And he took 4 spots on each bore to see what the sleeve thickness was. And so I got all of that data. It's pretty interesting. We'll go over this on another live feed, and then in the video that I'm going to do. But there's a lot of interesting information. And one of the things, I'm actually having him look at one of the spots that he did, because it seems really, really thin. And so I just want to make sure that that reading is right, because it's a little bit out of the norm, at least compared to all the others. And I think it's an anomaly or not an accurate reading or something. So I kind of want to see what's going on there. But we're boring that 4/8 block to a 6 liter, and so a 4-inch bore. And so a couple of things will happen is that means it will be a 6 liter bore, a 4-inch bore, and the 4/8 stroke. So that will put it right at the displacement of, or within 1 cubic inch, I think, of the displacement of a 5.3. So it'll be a big bore 5.3. And then we have the big stroke standard 5.3. And so we can do some comparisons there. So we can find out, this bore versus stroke thing. One of them obviously has a longer rod, so all the rod guys can talk about that. I mean, there's lots of stuff. So we can run, as long as I've got to do the math on it. I haven't done that yet. I need to figure out what we need to do for the compression. So I want to make sure, because the unfortunate thing about changing the bore and stroke, even if you made the displacement the same, the compression is not the same. Because bore and stroke affect it differently. So I want to make sure that the compression would be the same, so that we don't have that to bicker about. And then we could run it and see. We can run it, from 2,000, from 600 RPM, from off idle, from 2,000 RPM or so up to whatever we want, and then talk about what the difference is, if there are any, the differences in the power curve, running the same things, like the same heads, the same cam, the same intake manifold, same headers, all of that. And so that would be an interesting thing. It'd be really cool just to do the D-stroke 6 liter, because we know what that's going to do. It's just going to make less power. And I was thinking about that today on this D-stroke thing. I was thinking about the small block Ford deals, because when we talk about revving motors, like the Boss 302 comes up a lot. And so, because I did the comparison between the Boss 302 and the DZ 302. And so everyone's bickering back and forth about the 69 Camaro and the 69 Mustang and blah, 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 blah. But I was thinking about that. And what I can tell you is that something that nobody in Trans Am did, because there was a 5 liter displacement limit, and this goes to the thing that we always talk about, is something that nobody ever did was nobody de-stroked their 302 to make it a 289. Nobody did that on the Ford side, so that it would rev. Nobody did that, because they know that doesn't make as much power as just revving the 302 that you have, which is a 3-inch stroke, which is still a fairly short stroke, but it's not a 289 stroke, which I think is 287 or something like that. So again, more on the D-stroke stuff. But on this 4/8 stroke 6 liter, it's just going to make less than a 6 liter does, because that's what happens when you change the displacement. No matter how you do it, it's going to make less. But it will be an interesting comparison between the 5.3 and this 5.3, just with a change in board stroke. So it'll be kind of cool. Made it. I'm looking to add 1320 TVS supercharger to my 2 liter. Oh, that's a lot. I have a double butterfly throttle body, 245 millimeters. Do you think this will be too touchy on tip-in? Is there any way you can get them to open progressively? Speaking of Jimmy's, Tahoe has a transmission. It's ready to go in. We have a Summit transmission that's ready to go in. He's just building the shop right now, and so that's why it's not done yet. But I think it's going to be pretty soon. Steve Morse is making big bore 5.3 blocks with sleeves and thick deck surfaces. He wants $6,200. How is this beneficial? Wouldn't you just buy an aftermarket block? You can, but is an aftermarket block going to solve your problem? I know that we've done sleeved blocks before. We did Darton stuff. I think what he's doing might be better. It'd be interesting to try. I mean, he's the guy. He knows how to make lots of power. So I'd be surprised if he didn't test that. But one of the things I asked him, because he showed me all that when I was there, and I thought it was pretty cool. But one of the things I asked him, I said, well, okay, you fixed that part of it. I said, but now what about the main side of that? He goes, yeah, that's the next thing. I said, yeah. I said, I don't know. I mean, this is why people buy blocks, because there's not one problem with this in terms of structural integrity. And even from a frequency standpoint, the block's not designed to do what we're asking it to do. Not we, but what other people are asking it to do in these high power things. And they just don't, they're not built for that. And so you change that and go, okay, I've cured I think what he was interested in is the head sealing issue. I've cured that. Okay. But what about the bottom end strength now? And he's like, yeah, that's definitely a thing. 550 is idle. We got to start it there for wide open throttle testing. Yeah, that's not a thing. Roughly equivalent to a single 65. It's drive by wire. You can adjust the response curve. Biggest bore, shortest stroke, longest rod. Hopefully you'll get good news from the bore out 6-liter. Well, it's going to run, so that's not going to be a problem. On the 6-liter stuff, though, the machinist told me that he said, yeah, I go to 4065 stuff on the iron blocks a lot. I said, but have you ever measured the measured the sleeve thickness? Have you ever magged these for these people? He goes, no, none of these guys want to pay for it. I said, okay. I said, I would want to pay for it. I'd want to know what that is. He said, obviously these guys are not doing it with boosts because we wouldn't have them do it. And that's one of the things we'll talk about, because you got to look at this very specifically and scientifically when you're looking at what these thicknesses are. First of all, they're not the same all the way around. So there's core shifts. So the sleeve is not centered and not the same thickness. Like I said, it's not concentric. And so now, is the sleeve thick where you would want it to be thick, like on the loaded side, and thin on the unloaded side? If you have to choose one or the other, that's how you would want it. But is it like that? I kind of doubt that it would be like that. He's all about clamping things on. How long will it take before the turbo kit's available with air to water? I don't know. How's our poll doing? Is a single pass air to water intercooler really a benefit compared to a dual pass on a streetcar? 53% are saying no. I think Steve Morse blocks are for class racing that require a stock block or stock appearing. I don't know. That would be an interesting thing. I don't remember him saying that when I was back there. With your bigger turbo spool to 10 pounds by 3,000 on a 408 with AFR. I know the cam is bigger than you recommend. Yeah, that would hurt you, that cam. And I don't know what intake it is on there. The intake will actually hurt you also. And it's probably not going to do that in first gear because you don't have very much weight. That's the nice thing about the Tahoes. It definitely loads the turbo. But we're going to run the G42 on Jimmy's S2000. So we'll see some stuff there. That's a 2.4, I think. 2.3 or 2.4 liter. His has I think a Brian Crower like stroker thing in it. So that should be good because he's got I think he has a G30 on it right now. I think we have some others that we're going to try also. It'll be interesting. I just like to get lots of data points. So we'll obviously have stuff that we're going to try on the Tahoe once we put the 4L80 in it, but then also try that on his S2000 and then also on the 3.5 liter that he has in the NSX. So we can get a bunch of data points and go, hey, look, it spools up at this RPM on the small one, and on this RPM on the slightly bigger one, and on this RPM on the bigger one. That's all good stuff. Stock blocks are not created equal, all of them. No, they're not. What size primaries would you run on a 6-liter LK4 truck plus? What size primaries for the headers? I would run 1 3/4 or 1 7/8. It's not really going to make a difference. I doubt you'd even be able to see or measure any difference. We have to look when we do 1 7/8 versus 1 3/4 headers, we have to look very closely at the power curve to see where the fluctuations are. One of them isn't, oh, look, this one's 20 better. I haven't ever seen that. I would like to. The 363 small look forward is good. I like those. I have built, I had a Dart one of those, and that worked really good. I think that one made, it had a good size cam in it. I think it made 560 or 570. Jimmy's NSX is a great car. You use Draggy and video camera in. Yeah, he's got a Draggy in it, and we have some video of it when he was when he first put it together. And I've ridden it, and it's fast. Single pass intercoolers were good enough for 250 GTO and F40, so it's good enough for a GLH. Yeah, there are definitely frogs in the background. We've got a bunch of them in the creek behind us, and then next door they have a pool that's not a pool anymore. Yeah, I like the draggy stuff. It's pretty impressive. It's what I wanted the it's what I wanted the Vericom to be, but was not from back in the day. But man, we did a lot of, at least I did a lot of testing with the Vericom stuff. Stock blocks. After seeing seeing results in the real world with the turbo stuff, like in the Tahoe, I can see why, there's a big difference in the boost response in different gears. And so I could see why there would be big responses in gear changes, like rear end changes. And then also obviously vehicle weight. I mean, if you're talking about a 2,000-pound car, it's going to be completely different than it would be in a 3 or 4 or 5,000-pound car. And then if you have a 5 series gear or 4 or 3 or 2 series gear, when you test 1 3/4 versus 1 7/8 headers, are results more of a resonance thing where gains are going to be in a certain RPM? No, it's not specific. It obviously varies greatly with our test motor on what's going on. And then the times when I had seen big changes in power from that, like we did 1 3/4, 1 7/8, and 2-inch on a Kenny Bell supercharged 5.4. I think it was a 5.4. I don't think it was a 5.8. A 5.4 4-valve motor. And there were pretty sizable changes in power from that, which I think, given where they were more about flow than they were about a scavenging effect. But we see variations in headers like that on the NA stuff. Like in 1 7/8 headers, I've seen instances where it adds low speed power and then drops down below the 1 3/4 and then gets, and I'm talking about not big swings, but enough so that you see that something is going on there. I remember posting some header results and people were saying, oh no, this guy told me that 1 7/8 headers would be worth 20 horsepower of the tire over my 1 3/4. I'm like, well, I don't know what to tell you. I'm not going to tell you that guy is trying to sell you something. He obviously is. I said, but we have never seen that. I've never seen anything like that in any of the testing that I've done that indicates that you would see that kind of change from what you're describing, because we just don't see anything like that. If you're replacing sleeves, why can't you bore them on a lathe to make them even thickness? A sleeve, when you're sleeving a block, you do make them the same. They start out, the sleeve is the same. A sleeve is not the same as you casting a block, which is what they're doing, because that's a different thing. But when we do dart and sleeves, all the sleeves are exactly the same thickness. Or what Steve is doing, what Steve Morris is doing, all of his sleeves will be exactly the same, and they'll be the same thickness in every direction, because it's a perfectly round cylinder. If you just run a wastegate with a spring for your turbo kit to control boost. How does that act? Say like a 10-pound spring. That's all you use for the controller for long-term use. It's fine. The only thing is that a 10-pound spring doesn't always guarantee you 10 pounds, because the 10-pound thing is also affected by back pressure. So a 10-pound spring on a turbo on a 4.8 is going to react differently than a 10-pound spring or on a 2-liter than it is on a 454 or a 540, because you'll have more back pressure and it will want to open the wastegate. There'll be more back pressure acting on the wastegate against that 10-pound spring and the boost reference that you have. So you may or may not get 10 pounds depending on what combination you put it on. Here I can get information on LM753 swap into a Fox body, a budget build, of course. Are you trying to figure out what things that you need? Holly has a bunch of stuff on there, and if you go do a search for 5.3 Fox body swaps, there should be umpteen million different videos that you can watch on YouTube where guys have done that. I'm curious if there's a power limitation or flow restriction when hitting certain horsepower numbers. You're saying 1 3/4 can flow as much as any of the bigger ones, correct? I'm not saying that at all. An 1 7/8 header flows more than an 1 3/4 header. What I'm saying is that when we run that on the dyno, we are probably not at a flow limit situation. So if we run those on and I don't know what that number is. All I know is that when we tested it on that supercharged one, and I think we were around 800 horsepower, it seemed to make more of a difference. I've heard small primaries can help fuel mileage. That wouldn't surprise me. But I haven't done that testing though, where it's part throttle. Because for me, fuel mileage is not driving around on the street. For me, fuel mileage is a steady state, hopefully like with lots of miles to get an accurate number, but like a cruise steady state on the freeway at like, let's say 2000 RPM. And then under that situation, does a small primary help? I don't know. I don't have enough testing on that to figure that out. Pretty much want to know what is everything I would need to from start to finish the build. Yeah, you need to go do research. It's going to take more than one video, more than one source for you to get all that information. It's going to be a long shopping list. Yeah, it is. You got your work cut out for you. It's that level of knowledge doesn't just come simply. Yeah, you can ask AI. That's one of the sources. I wouldn't have that be my only source. But there are complete kits to put an LS into a Fox body, though. And I'm sure that Holly probably has some of that stuff. They probably have swap videos that you could look at. I wouldn't use them as the only source, but there's a lot of information available on YouTube for that. I just spent 60 grand on going to school to get the knowledge. Yeah, and I wouldn't just use that source. There's lots and lots of sources to get good information, and try to get it from wherever you can. I mean, I asked lots of questions when I was going to say when I first started going to WASTEGATES, but the whole time I was at WASTEGATES, even now, I ask questions. How can I get more low-end power from a 2003 Honda Civic 5-speed 1.6? Should I try porting the head? Porting the head is not going to get you low speed. Maybe a long tube header, certainly boost. More displacement will do it. You might be able to advance the cam or cams. There's kits to put LSs in a Miata. Yeah, there's kits for LSs and lots of stuff. Beef up the steering column holder and brake pedal on your Fox. The steering column holder and the brake pedal holder on your G42 turbo. What size downpipe is the minimum for 800? Yeah, it's set up to accept a 4, but you probably you could make 800 with a 3.5. But if I was trying to do 1,000, I would definitely put a 4-inch on it. And anything that you could do to make it bigger is going to be better on that turbo. M62 supercharger, that would definitely help low end. Although the thing I didn't like about the supercharger stuff on the Civic, when I was doing all the testing with Oscar Jackson back when he was running the Eaton stuff, is that they got rid of all the runner length in the manifold. And so you didn't see great gains down low. What's good? Bigger drive-by-wire throttle body for what motor is that for? Right? Yeah, compression could help everywhere. Well, it's 20 degrees. That's definitely boost weather. I think it's in the, probably was in the 80s today. Would I be okay running twin 770 ball bearings with 3-inch? I think that's on, I think that those are on the exit side of those are 3-inch, I think. They'll make the most power with a step from 3 to 3.5, but you'll be able to make a lot of power with 2 3-inches as opposed to just 1 3-inch. I guess I would have a boost activated valve to open a dump. Well, you can do that also, but I don't think you're going to be lacking power with running twin 3-inch from 2 of those turbos. Have you messed with compressed air injection? You mean compressed air supercharging? Is that what you're talking about? Yeah, we did a video with those guys. Snowmobiles run better when it's cold? I bet. That's what they need. They need boost on them. Get all that boosty goodness. Can you use an electronic wastegate as your boost controller? You know, set at 10 pounds. Yeah, if you get a really expensive Turbo Smart wastegate that's electronic, you can control it that way. You can also do it with an electronic boost controller that's a lot less expensive than an electronic wastegate. The controller will do that for you. And especially if you have some sort of standalone like a Holly or whatever, they'll control that. Throttle body for the LS. I'm using a BTR Trinity intake manifold. What is the guy's name that has the electronic drive-by-wire throttle bodies for LSs? I think that I can't remember who did those for them. I want to run them through some sort of Valvetronic mufflers, so wide open option and closed quiet option. If you can run mufflers after the turbos and have the mufflers not be loud and still flow really well, I don't know that you need a switch valve or anything. I don't, Scotch, I don't think you're going to need that. I think you just run good mufflers. It's going to be quiet. FT550 or Terminator X Gen 4 6-liter with a power glide, first gen Camaro, currently carb setup, been researching both. I don't know what FT550 is. I'm not familiar with that. KC Max, Ryan Mitchell is always worth a watch if you want technical information on racing with compressor or supercharging. Yeah, we had those guys on here. That Carl and Dale. That's good stuff. I was there when they tested it, when Jeff Smith did the first story on that for WASTEG, when they were at WASTEG, and I was there when they were testing it. It was amazing. FuelTech 550. Yeah, I'm just not familiar with that. I've never done any testing with that. I've done lots of Holly stuff, obviously, and Haltech and Fast early on, and then MS3 Pro on the what was that, on the 3800 maybe? No, on the 4200. on the Atlas motor. And are you, Mr. Landslide, what are you trying to do? Are you getting rid of the carburetor, and are you doing a turbo thing? What are you doing? Do you not like the carburetor, or you don't want to do a blow through a carburetor? No snakes today, just jackrabbits and quail. I went out and did a ride today. It's a little warm. Is there such a thing as too big of an air-to-water intercooler? Yeah, I would argue that if you put a giant air-to-water intercooler on a 200 horsepower like turbo Honda thing, like a single cam thing, that you're just wasting weight. And there's no reason to have that, because after you get to the point where it's not doing anything, it's just adding more water capacity and more volume that you don't need, that's not beneficial. I would say that, yeah, there's no need for that. I don't know that it's going to hurt you, other than the weight's going to hurt you and maybe response a little bit. But you cannot get the air too cold. So that's not a thing. I remember somebody at the Silver State telling me that. Yeah, I'm blocking off my oil cooler because my oil temperature is too low. I said, so you're running a wide open throttle in a Mustang and you think your oil's too cold? I said, your sensor's wrong. No, it's just getting too much airflow. I said, it's not. That's not a thing. That's not happening. And then later on, he would call a week and a half later. Yeah, sensor's bad. I'm like, yeah, I know. If you're running a wide open throttle, you're not going to have cold oil. What about the Icon? I think it may be by Steve Morstead, who maybe you're thinking of. I don't know what you're talking about, the Icon. One of the first things I did with my BMW was delete the muffler flap. It was stuck, and I didn't want to bother with it. Was that the fancy muffler? For a GM T900 with the turbo, would you use an air to water or air to air for like 400 torque and a tow? Well, 400 torque is not going to be very much for a turbo motor. It's probably going to be way more than that. If you have room up front, the reason that we chose air to water is because in that 05 Tahoe, there's not room up front unless you cut stuff to put an air to air intercooler on. And that works fine. And for the boost levels that most people would be running, that would work fine. We were able to mount the air to water intercooler under the bumper. And so you don't have to worry about, fitment. And then, so it will work on the earlier ones and the later ones. And the later ones, I think that they have room. So you can put an air to air there as long as it fits. I wanted to do a blow through carburetor, but they're very expensive when you go to dual needle and seats. Yeah, the CSU stuff is not inexpensive. It's really good, but it's not inexpensive. On a 4.8, yeah, 400 foot-pounds of torque, though, even on a turbo 4.8 is not going to be very much boost. Looks like the cost for a 50 millimeter wastegate with an electronic boost controller is about the same price as one electronic wastegate. And yes, my Holly can control it. Okay. Yeah, it's just a boost controller, just a 3-port deal. It's pretty simple. But you can also do a manual one. Dark Blaze, what's going on, man? So if you want it to be 10 pounds, and it's only 8, you just turn it up 2 and then just leave it alone after that. I've used the manual ones a lot. Did you ever find out what the engine was? I was working, didn't see it. Yeah, it's definitely an Olds. I don't know which Olds it is, but I'm going to go over and look at it tomorrow. But it looks like the bell housing area is seriously damaged. Otherwise, I wanted to go get it and run it. But if that's damaged enough, and I'll know that tomorrow, I think it is. I'm pretty sure it is from the photo. If it's damaged that badly, I'm not going to get it because I won't be able to like run it and enjoy it. BMW is a twin tip exhaust. The flap closes one of the tips to make it quieter. Okay. Modesto's in the house. Crazy idea, but what if I drill holes above the port and welded an adapter for injectors on a Gen 6 big block? Do you think that would work? Where are you welding? Are you talking about on a dual plane intake manifold? Because a Gen 6 big block is already EFI port injected. In your opinion, should I get a V10 Triton truck or a 350Z with the HR motor in it as a second vehicle? For reference, my first vehicle was the Nissan Xterra. Well, those are wildly different things. A V10 truck or a 350Z, those fulfill like completely different, they solve different problems. So you just got to grab which one speaks to you. I think the 350Z would be more reliable than the V10 truck. But a V10 is cool. But I don't think that most of the people that I've talked to have not said, you know what, this thing has really good power. They say this thing has really terrible mileage and also it doesn't make enough power to justify the mileage. With the Truck Plus cam, add 75 horsepower to a 415 LS3 stroker like it does to a 5.3. It would if you ran the stock LM7 camshaft in your 415 LS3 stroker. Is that what you're starting out as the base cam? That's what we're measuring it against. When the 350Z is the more reliable option. I know it kind of says something about the Triton, doesn't it? I thought manual boost controllers kind of sneaks up on the boost limit they bless before the target as the spring compresses. They bleed? Is that what you're talking about? Yeah, they're not ideal, but you can if you're set up because of your back pressure or whatever is only giving you 8 pounds and you want 10 pounds and you turn it until you get 10 pounds, you'll just get 10 pounds. You're just bleeding out some of the signal. It's not ideal, and the wastegate will start opening, a little bit earlier. It won't have a dual port going to the top and bottom of the wastegate where it holds it closed, although you can do that with a manual controller if you configure it correctly. But we're nitpicking. We're only seeing like, oh, look, we could have a little bit more power right here if we held it closed. We could also just turn the boost up 1 pound and have way more than we're even quibbling about right here, and we'd have more power everywhere. So again, that's not something that's worth, like, I don't think it's worth discussing. Get the small twin turbo kit from Jimmy. Oh, got the small twin turbo. Okay. What's your favorite aftermarket head for an LS 4-inch for boost? I don't have one. I don't have favorites for lots of stuff. There's not that. For a lot of people, they want absolutes like that. Like, what's the go-to camshaft, or what's the go-to head, or what's the go-to? There isn't that. I don't do that. I test all of them, or as many as I can, and so that you guys get to decide whatever it is you want. What I can say in most applications, whatever kind of power you're trying to make, the head's not going to be holding you back. Because if you just get an aftermarket head that has a thick enough deck, and then you probably are going to have to worry about the block anyways, unless you have an aftermarket block. Because just because you've solved the head thickness problem and you have head flow, whatever turbos you have is going to dictate what the power output is. And then if you have a good head on a stock block, it's not worth discussing, because the block is going to be the problem. Especially if you don't, do you have forged rods and forged pistons and a forged crank? Do you still have a stock block? Because if you still have a stock block, that's going to be the limiting factor. For me, the go-to is the cookie cutter build. Build something that fits what you want out of the engine. Exactly. Just do whatever, like we were talking about the other day. Putting a 4-barrel quadrijet on a 350 was awesome. Replacing the 2-barrel with a 4-barrel was like 100% awesome. Is that my favorite thing? No, but it was really, really cool. Just like with the Sprint turbo stuff. When I doing all of the chassis dyno testing and getting 1 or 2 or 3 horsepower at a time on the Sprint turbo was awesome. Doing the Sprint turbo stuff before we went and set the records out at Jimmy's place at HP Performance in New Mexico before we drove to Maxton, North Carolina, was awesome because we could turn the boost up and it was working okay. We couldn't configure it the way that I wanted. Now that we'll have standalone management on it, we'll be able to dial it in. Can you reuse MLS head gaskets? Yes. Yeah, we reuse them all the time. When I'm doing NA head testing, we use the same head gaskets for 7 or 8 or 10 different sets of heads. I've seen folks unshroud the valves and combustion chambers, but what about taking down sharp edges in the quench pad? Do you believe that would be beneficial? Yes, it is. Softening the chamber is definitely beneficial. A vacuum-operated wastegate will start to open before it reaches the target boost level. The electronic ones hold the gate closed until the target boost is reached, but the difference is minor. Yeah, and the way that they do that, just being electronic doesn't do that. They also have to have vacuum and boost ports going to the top and the bottom of the wastegate to be able to hold it closed and then release it. And they do that electronically. All they're doing is opening a solenoid. Do you ever put boost on the Trophy 4? No, I haven't run the Trophy 4. It's ready to run, but I haven't run it since it was not working very well when the cams was worn down. If I get a 350Z, how much horsepower can I push stock with turbos? You're gonna have to at least put ring gap in it. And then I don't know. I'm not a VQ or whatever motor that is. I haven't ever run any of those. So you could go online and see what people are doing. When I had my 83 RX-7, everyone was saying junk the rotary and V8 swap it. If I just rolled my eyes and built a 700 horsepower 13B and dominated all the V8 swap RX. Well, yeah, dominate all the V8s is not probably a real thing. But yeah, you can make lots of power with rotaries. But you can also make lots of power with turbo V8s too. A 700 horsepower 13B, a turbo 13B is probably not that reliable, is it? I'm not a rotary expert. Sure, there's lots of information on turbo VQ engines. Yeah, there's got to be a ton. But I would think that 500 or 600 horsepower is not going to be a problem with that motor to have it around and be able to drive it and have it live. Yeah, Jet, I'm not buying the displacement that they apply to rotaries. It's more like a 2-stroke. I can't find a clear answer online. What's the biggest bore I can make when sleeve in LQ4? It will be NA. If you're doing sleeves in it, usually the sleeve manufacturer will tell you, okay, the sleeve is this thick, and then you can bore that out to this size, and you obviously can't bore it out so that the holes like overlap each other. But usually, I think I went to 4,185. I think you could go to 4,200 maybe, but that was as big as you could get. But with the sleeves, you could also put a really long stroke in it. So we made 468 inch motor out of the sleeved aluminum LS6 that I did. They're way more reliable than a factory 13B. It's all in the Apex seal materials. Okay. Is it bridge ported or is it peripheral ported to And what RPM is it running? Because 700 horsepower with a turbo one, it's got to be RPM too, right? I remember there was a Gen 3 RX-7 that raced against us in World Challenge. And he wasn't making 700. I think he's probably more like 550 or 600. But he had to do hour races though. So road racing is a different thing. I like those cars. A friend of mine had an 81 RX-7. I loved it, but I like the Gen 3s even better. Gen 3 is 13B is in fact 80 cubic inches. 1308 cc's. So how are they measuring? What's the bore and stroke on that? I know it. I know the displacements that they gave it back when they were racing them in GTU, and everybody complained about it. Well, all the people that were losing to them complained about it. The same thing with Bonneville, getting the displacement of that relative to a piston engine. Like I said, I'm a big fan. They dominated GTU for a really, really long time. And I loved watching them run. Loved watching the Mazda Kudzus because they were on the track with us, watching their little Bunsen burner exhaust like melt the tarmac as they were racing around, seeing it glow at night. It was really cool. We've got one more minute. I'll get rid of our poll here, 61%. We're going to end our poll. I wish that I had a 12A or a 13B so I could run it on the engine dyno. I kind of want to play with one. I've reached out to a couple of Mazda people, but nobody's been able to help me yet. I even reached out to a wrecking yard that has a ton of, or look like a ton of RX-7 and RX-2s and 3s and 5s and whatever. Got one more minute. Gen 4, 496, 294, Brodex heads, forged internals, flat top. What size turbo recommendation for 1,000 wheel horsepower? We don't have anything that will do that for that motor. We have a G42 1450, but I think the hot side is going to be too small for that. So I don't know, S485 or something like that. Probably Viren over VS has something that he could get you. The Cobalt folks really enjoy their dual pass end plates. Nathan, what's going on? You could run on your 496. You could run twins. We have twins that will do that. Cobalt SS. Is that the supercharged one or the turbo one? I kind of like those cars. I like the Mini Coopers too. Frogs are going at it. Which twins for 496? I think for yours, I would do twin 3584s or 3582s. Edward, I'm happy to help, man. Yeah, twin 3582s would be enough for that. And then you could go up in power if you wanted to. Just been making new RF shields for my ignition. Do you have a Corvette or something? Contemplating doing a turbo on my ZX14 because that needs more power. Thanks. I don't want to blow the stock block. Yeah, you know running 7, 8, 10 pounds or whatever will be fine. Supercharged ones had dual pass as an option upgrade. Tons of room. Oh yeah, that would be good then. Yeah, those twins would be good, and it looks, it's twins. It would look better. Oh, and it's a 2-bolt. Yeah, no, you're probably 1,000 wheel. I think is a little tall order maybe on that motor. Everything needs more power. That's right. We tested running 100 shot. Are you talking about the boost pressure to back pressure is 1.5 to 1? So 1.5 is not very much. You're not anywhere near spinning the turbo where guys that are racing are spinning the turbo. 100 shot will bring that up. So with blowers, the larger blower making the same boost is less heat and better efficient. I wouldn't make that as a general statement. I would say that the larger blower can make more power, and if you spin it slower to make the same boost, which is what you would do, it will probably have less parasitic loss. It might, if the Kenny Bell, the data that I've seen is correct, but it will be less responsive though. So if you get them, because here's the thing, you can't have them making exactly the same boost curve all the way through the RPM range. They won't do that. So if you get them to match the same boost at some point, what's going to happen is the smaller blower probably will have spun up faster. So there are differences there. Tell us forward dart and sleeve the turbocharger. How can I make this budget build? My goal is 1,000 horsepower. I'm going to detune it because it's what I have already. Are you doing this in some front wheel drive thing? I have the opportunity, misfortune, of becoming the owner of an 81 Malibu 267, the Turbo 250. When you use it for a T-bucket, is this a horrible plan? No, if it's what you have already, it will work. It's actually around 2 to 1. Gates for sure are closed. 800 wheel on a 2,200 pound car sounds right. Yeah, that would be more than enough. That'd be pretty sporty. And on that note, I will see you guys all tomorrow. There.